There is a moment every home gardener knows. You walk out to your backyard on a summer morning, coffee still in hand, and you stop. The tomato plant you have been tending for weeks is not right. The leaves have turned the color of old paper. The stems are bending toward the ground. The flowers that opened just last week have already closed for good. And a quiet voice in the back of your mind says the same thing it always says. It is over. Time to pull it out. Most of us do exactly that. We grab the shovel, pull the plant up, and tell ourselves we tried our best. But here is what soil scientists who study plant decline have found, and it changes everything. In nearly every single case, a plant that looks finished is not finished at all. It is simply running out of one or two specific nutrients the soil can no longer provide. And every one of those missing nutrients can be delivered back to the plant in as little as saship-pal hours, using nothing more than items already sitting in the average American kitchen. Not a trip to the garden center. Not another bag of blue crystals at $2 a box. 5 zero-cost liquid fertilizers, tested in university soil labs, used by generations of farmers long before synthetic fertilizer ever existed, and quietly ignored by the lawn and garden industry for one very simple reason. There is no way to put a logo on a banana peel. Today, we walk through all 5. What each one does, why each one works faster than anything sold in a store, and the one mistake almost every gardener makes that keeps these methods from working the way they should. If this is your first time here, hit subscribe. We cover the kind of gardening knowledge that does not come with a price tag. Let us start with something sitting in almost every kitchen in America right now, something most people throw away without a second thought. Here is a question worth sitting with. When you peel an onion tonight before dinner, which part carries more potassium, the white bulb that goes into the pan, or the dry papery skin that goes straight into the trash? Most people guess the bulb. Most people are wrong. It is the skin. Those thin, crinkled outer layers carry concentrated doses of potassium, calcium, magnesium, and iron. They also carry a compound called quercetin, the same protective compound found in apples and blueberries. Inside a plant, quercetin shields leaves from harsh summer heat, slows the spread of fungal infection, and steadies the plant's internal chemistry when temperatures swing hard. Now here is where most gardeners take the wrong turn. When people first hear about onion peels, they imagine burying the skins directly in the soil. That method works, but it takes weeks. The nutrients stay locked inside the dry fibers, while the plant above continues to wilt. By the time those skins decompose, the plant is already gone. The real trick is water. Water pulls minerals out of plant tissue the same way a tea bag releases flavor into a hot cup. A handful of dry skins, 1 quart of cool tap water, a glass jar with a loose lid, and ishipsa to saship-pal hours at room temperature. That is the entire setup. Within a day, the water begins to darken. By the second day, it turns deep amber, and that color means potassium, magnesium, calcium, and quercetin have dissolved into the liquid and are ready for roots to absorb immediately. No composting. No waiting. Pour that liquid at the base of a yellowing tomato or a pepper that has stopped setting fruit, and within days the difference is visible. Stems thicken. New leaves come in a deeper grain. The plant's defense system activates. Stem rot slows. Seedling wilt fades. The next time you peel an onion for dinner, drop that skin into a jar of water on your counter. One small habit that costs you exactly nothing. Now let us move to something that happens in millions of American kitchens every single evening without a second thought. You rinse a cup of uncooked rice, and that cloudy white water goes straight down the drain. But what if that water turns out to be one of the most powerful soil treatments ever studied under a microscope? Fresh rice water carries starches, B vitamins, and small amounts of iron and zinc. Mild benefits, nothing dramatic. But leave that same water to sit in a covered jar at room temperature for to 0 days, and something completely different happens. A faint sour smell develops, almost like the early stages of a sourdough starter. Most people would pour it out at that point. Doing so means throwing away the most valuable part. That sour smell is the signature of a microbial bloom. Lactic acid, bacteria, and wild yeasts have moved in and multiplied inside the liquid. In the Chungubekpa sheeps, a Japanese agricultural researcher at the University of the Ryukyus introduced the concept of effective microorganisms, a group of beneficial microbes that, when added to depleted soil, could restore it to life within weeks. His research became the foundation of farming methods now practiced in more than Begoship countries. And the microbes at the heart of that research are the exact same microbes that appear naturally in fermented rice water at zero cost. When applied to your garden bed, those bacteria and yeasts meet the microbial community already living around your plant roots. The starches in the rice water feed them. The soil microbiome wakes up, multiplies, and gets to work. Within a single week, the beneficial microbe population around a treated plant can triple. Here is the way to think about it. Rice water does not feed your plant. It builds the system that feeds your plant. The difference between handing someone a single meal and handing them a working kitchen: one runs out, the other keeps producing. Always dilute fermented rice water, 1 part to ship parts plain water, before it touches the soil. And remember, if the liquid does not carry that faint sour smell after Sam to O days, it is simply not ready yet. Patience here is the whole game. Rice water rebuilds life in the soil, but a plant collapsing today cannot wait for a slow rebuild. It needs nitrogen, and it needs it now. Which brings us to the third method, and this one might be the most surprisingly powerful of all 5. Think about what is sitting in your refrigerator right now. The tomato that went soft before anyone used it. The cucumber pushed to the back of the shelf. The wilted spinach. The bruised kale. The overripe pepper. For most households, these scraps go straight to the trash. But for a gardener who knows this method, those same scraps are the fastest acting nitrogen source that can be made at home. To understand why, you need one idea from a German chemist named Justus von Liebig back in the Chunparbek-Saships. He called it the law of the minimum. Imagine a wooden barrel built from staves of different heights. The water inside can only rise as high as the shortest stave. It does not matter how tall the others are. Plants work exactly the same way. If your tomato has plenty of potassium and phosphorus but not enough nitrogen, growth stops at the nitrogen line, full stop. And in nearly every American backyard garden, nitrogen is that shortest stave. Green kitchen scraps are packed with nitrogen. When those scraps are crushed and placed into a gallon bucket, covered with water, weighted down with a plate to keep them submerged, and left to ferment for about 8 weeks, bacteria break the plant cells apart and release that nitrogen directly into the liquid. The finished product is dark, cloudy, and strong-smelling. That smell is the proof it is ready. The most important warning with this method is the one most gardeners ignore. Never spray this liquid on leaves. Never pour it undiluted. Dilute to a part, liquid to semship parts water. Apply directly to the soil at the base of the plant and never on the leaves. Follow that rule, and within Sadayuk days, pale tired leaves deepen to full rich green, new shoots emerge, and a plant that looked finished on Monday can be setting new flowers by Saturday. So far, each method has solved one specific problem. But what happens when your plant is not missing just one nutrient? What happens when it is missing 5 or 6 all at once? That is when you need a full spectrum formula, something that covers nearly every deficiency in a single pour. And it turns out that formula already exists, built entirely from what most American households throw away before breakfast every morning. Banana peels from breakfast deliver potassium, the mineral that drives flowering, fruit production, and the plant's ability to move water through its cells. A tomato plant short on potassium produces small watery fruits with skins that split as they ripen. Finely crushed eggshells provide calcium carbonate, the building block of cell walls. Calcium deficiency is the exact cause of blossom end rot, that black sunken patch at the bottom of an otherwise beautiful tomato. Used coffee grounds from your morning brew add a slow, steady release of nitrogen while feeding earthworms and improving soil drainage. Before we go further, here is a myth worth correcting because it has been repeated online for decades. Gardeners are often told that coffee grounds make soil acidic. That is only true of fresh, unbrewed grounds. Used grounds that have already passed through your coffee maker measure between Yukjum O and Yukjum Pal on the pH scale, nearly neutral, and right where most vegetable gardens want to be. Used grounds will not acidify your garden. They will feed it. 2 more ingredients take this recipe from good to genuinely exceptional. Epsom salt, which is magnesium sulfate, addresses one of the most common and most overlooked deficiencies in home gardens. Magnesium sits at the center of every chlorophyll molecule in every green leaf. Without it, leaves yellow between the veins, while the veins stay green. 1 tablespoon dissolved into the brew can reverse that pattern within days. Use it when you see that specific symptom, not as a general habit, because adding it repeatedly when the problem is something else can gradually throw your soil's overall balance off. The second addition is blackstrap molasses, not regular table molasses, the dark bitter variety from the final stage of sugarcane processing. Its real job in this formula is to feed the microbes. 1 tablespoon of blackstrap stirred into the brew multiplies the beneficial bacteria in the liquid within hours. Without molasses, this brew takes about some weeks to become fully useful. With molasses, it is ready in some days. To make it, combine banana peels, finely crushed eggshells, used coffee grounds, 1 tablespoon of Epsom salt, and 1 tablespoon of blackstrap molasses in approximately a gallon of warm water. Cover loosely and steep for some to 2 days. Apply at the base of your plants, never on the leaves. The 5th and final method is older than everything else on this list. Older than coffee and bananas in American grocery stores. Older than most of the houses in any town where you are watching this. This method was the backbone of American farming for generations before synthetic fertilizer ever existed. Before Chungu Bekshib Sam, every farm from the fields of Iowa to the hills of Appalachia ran on 2 inputs only: animal manure and compost. Then a German chemist named Fritz Haber, working alongside an engineer named Karl Bosch, developed a process to pull nitrogen from thin air and convert it into ammonia. That invention, now called the Haber-Bosch process, made it possible to feed billions of people. But it came with a trade-off almost no gardening book explains honestly. Synthetic nitrogen fed the plant while quietly starving the soil. Decade after decade, the living microbial communities beneath the surface were replaced by chemical dependency. The results are visible today, in the dead zones spreading across the Gulf of Mexico and in the declining soil structure across the Great Plains. For a home gardener, the old method still works. Old-time farmers in Appalachia called it the giant tea bag, and once you understand the setup, you will see exactly why. Place a shovelful of age-dried manure inside a porous sack. An old cotton pillowcase or a mesh laundry bag works perfectly. Tie it shut and drop it into a gallon bucket of water. Over some 2 days, the water slowly draws out the soluble nutrients, nitrogen, phosphorus, potassium, and trace minerals, leaving all the solid matter safely inside the sack. Aged chicken manure is highest in nitrogen and phosphorus, making it the strongest growth stimulant. Aged cow manure is more balanced and better for building long-term soil structure. Rabbit manure is the gentlest of the 3 and the safest option for young seedlings, as it can be used with less aging than the others. The single most important rule with this method carries no exceptions. Never use fresh manure. Fresh droppings carry too much ammonia, too many weed seeds, and too many pathogens. A single bucket applied too generously can scorch an entire row of seedlings within sashapal hours. Manure must be fully aged for at least months before it ever goes into the tea bag. Once brewed, dilute the tea to the color of weak iced tea, roughly part to sip parts clean water. Apply during the cool hours of early morning or late afternoon. In the heat of midday, nitrogen evaporates from the soil surface before roots ever get the chance to absorb it. That one timing adjustment alone can meaningfully increase how much benefit your plants receive from every single bucket you brew. 5 methods. 5 liquids. Every one of them built from what most American households throw away before the day is half over. And every one of them capable of showing results inside a week, with some working in as little as days. Onion peel tea delivers potassium, calcium, magnesium, and quercetin directly to the roots. Fermented rice water rebuilds the invisible living system in your soil that makes all feeding possible. Vegetable scrap digestate floods the root zone with nitrogen when a plant needs emergency rescue. The kitchen cocktail covers nearly every deficiency at once, with 5 ingredients from your morning counter. And aged manure tea brings the most complete fertilizer system ever used by American farmers. A living brew that feeds the plant, feeds the soil, and feeds the microbial communities that keep everything thriving long after the season ends. What ties all together is one idea that is easy to forget in a world built around buying solutions off a shelf. The things we call waste in a modern American kitchen are, in almost every case, exactly what a struggling garden needs. The nutrients were never scarce. They were simply going to the wrong place. So here is what I want you to do tonight. When you peel an onion for dinner, do not throw that skin away. Drop it in a jar of cool water and set it on your counter. That is where this starts. One small habit, repeated consistently, and within a single growing season, you will see your garden differently. Leave a comment below and tell me which of these methods you are trying first. If you know a fellow gardener who has been losing more plants than they have been saving, share this video with them. And if you have not subscribed yet, now is a good time. There is a lot more where this came from. Happy gardening!